Coterminal angles are angles that share the same terminal side. So how can two different angles be coterminal and share the same terminal side? The way that happens is by taking an angle and then going another entire circle of 360 degrees, either counterclockwise in the positive direction or clockwise in the negative direction. Because each time that we turn 360 degrees, we get back to the exact spot where we started, right? And we can do that again in both directions, and we can also do it multiple times. So for our next two examples, let's do this. Let's find two coterminal angles to the given angles, one with a positive measurement and one with a negative measurement. For angle theta of 450 degrees, we can now go and subtract 360 degrees, see where we get. 450 degrees minus 360, that's 90 degrees. So an angle of 90 degrees is a coterminal angle to an angle of 450 degrees, and this angle of 90 degrees is positive, so that was the first thing we wanted to find. Now we want to find another coterminal angle with a negative measurement. Then we just keep subtracting 360 and see where we get. And we can already see that subtracting 360 from 90 will get us into the negative territory, negative 270 degrees to be precise. That is an angle with a negative measurement, and it's another angle that's coterminal to the angle theta of 450 degrees. The same we can of course do with an angle whose measurements are given in radians. Angle alpha has a measurement of 21 pi over 4, and we can do the same thing to find coterminal angles, but since this one is measured in radians, we're not going to add or subtract 360 degrees. We're going to add or subtract a whole circle measured in pi, and that would be plus or minus 2 pi. Remember, that's a whole circle. Now, to make things easier on us, we're going to convert 2 pi into a fraction with a denominator of 4. So that would be 8 pi over 4. And now let's find two coterminal angles, one with a positive measurement, but we are going to start going in the negative direction anyway. So subtract 8 pi over 4. We get 13 pi over 4. And that is a coterminal angle with a positive measurement. And now let's keep subtracting. Minus 8 pi over 4. That'll give us 5 pi over 4. This is coterminal as well, but it's positive. That's not what we wanted. So we need to keep going. Subtract 8 pi over 4 one more time. And now we're going to end up with an angle of negative 3 pi over 4. And that angle of negative 3 pi over 4 is another coterminal angle to alpha, and it has a negative measurement. So how can we find all coterminal angles to beta, and beta has a measurement of 120 degrees? Let's draw our angle here to have a better view of what's going on. Our angle beta of 120 degrees is going to start at our initial side, going 90 degrees up through the first quarter, and then 30 more, which makes it land about here. That's our angle beta. For each coterminal angle, we have to start here and go an entire circle of 360 degrees. We can do that once, we can do that twice, we can do that 3 times, as many times as we want. We could also go in the opposite direction, then we would go -1, -2, -3, and so on. So we are going to write this the following way. All coterminal angles to beta, they start off with 120 degrees, but then we add 360 degrees to it, and we do that full times. 1 time, 2 times, 3 times, and so on. So times a constant k, and that number k has to be an integer. It can't be a decimal or a fraction or anything. It can be an integer. That means a whole number, positive or negative. That's all we do. Just take our initial angle and add 360 to it k times. K can be any number that's an integer, positive or negative. The last thing I want to do with you today is talk about converting between degrees and radians. Remember, we said a whole circle measures 360 degrees, and that measurement in degrees is equivalent or equal to measuring the circumference of the circle with 2 pi. And that's the equality that we use to convert. Because if 360 degrees is equal to 2 pi, what does that mean for 1 degree? 1 degree is equal to 2 pi divided by 360. And we can clean this up and simplify, and we get 1 degree is equal to pi over 180. Likewise, 1 radian is 360 divided by 2 pi. Just the other equation flipped. And again, we are also going to simplify this to get 180 over pi. And these are the two formulas we're going to use to convert measurements from degrees to radians and back. Here are our examples. Let's convert 30 degrees to radians. 30 times pi over 180. That's equal to 30 pi over 180. And we can simplify that. 30 goes into 186 times. So that is pi over 6. And converting 3 pi over 4 into degrees. 3 pi over 4 times 180 over pi. That gives us 3 times 180 is 540. 540 pi over 4 pi. The pi's get canceled out, and 4 goes into 540 135 times. And that leaves us with 135 degrees. Remember pi over 180 and 180 over pi for these conversions. And if you get confused which to use where, just think about it. If you go from degrees to radians, you want to have a pi somewhere in that answer. So you needed to use the pi in the numerator. If you go from pi or radians to degrees, then you want to use the formula with the pi in the denominator. So the 2 pi's cancel each other out. All right, that's it for today, and I will see you in class.